me. Let's get started. Please, on problem solving, we've got a few rules that we're going to talk about today. And the reason why we're going to cover how to solve a problem, and I know probably since 4th grade or 5th grade, you started looking at how to solve problems, but I don't know that you really followed a set of guidelines. I look at my son's math homework that he comes home with all the time, and there's not necessarily rules that he follows to make sure that he comes up with the correct answer. And so what I want to do is I want you to jot down these rules for solving problems, and then we'll use those rules to solve a couple of them. And the reason why we want to tackle this before we move on into talking about speed and velocity and acceleration and the motion of objects is because if you don't follow these guidelines, sometimes you come up with answers that they're not appropriate for what just happened. Let's say, for instance, we got a word problem about a cat that fell off the countertop, okay? And if you come up with an answer that says that its speed right before it lands is 30 meters per second, well, number one, you got a dead cat. And number two, it's not a reasonable answer. So we use these rules just as guidelines for solving problems, and it fits nicely here nice and early because for the next few months, we're going to be solving problems related to the motion of objects, okay? So go ahead and pause it, jot down these rules, and we'll continue. All right, so you've jotted down the rules. Now let's just look at them real quick. Hold on, let me go back. All right, read the problem carefully, makes sense. When appropriate, draw a diagram. I draw diagrams all the time. I think it's a good habit to get into. When appropriate, there'll be times where you might not need to, okay? Write down what you know and what you're trying to find, and make sure all the units are converted into the like units to make the math easier, okay? Determine the correct equation to use. We're going to see a number of equations over the next couple of months. All right, perform the calculations, and then probably the most important one, consider if the results are reasonable. All right, so here's an example. Go ahead, pause it for a second. Take a look at the example, read it to yourself, write it down, go through those steps. Are there any conversions that need to be made? And then we'll go ahead and work it out, okay? So pause it. Jot it down. You're going to get, again, credit for taking notes on the screencast today. I am going to, since this was homework over the weekend, I'm only going to give credit if you have the notes starting tomorrow morning when you come to class, okay? So go ahead and pause it for a second and jot that down. All right. Hopefully you took a second and jotted down this example. So it says a closed cylindrical container used to store material from a manufacturing process has an outside radius of 50 centimeters. I don't have a meter stick, but that's half a meter. All right, and a height of 1.3 meters high. We're probably talking about here. Okay, what's the outside surface area of the container? The outside surface area is going to contain the lid, the bottom, and then the whole wrapped portion of the cylinder. All right, so that's the example. We've read it. I definitely see a conversion that needs to take place. I think you need to take the 50 centimeters and put it into meters so that we have like units throughout. Okay, I already said it's half a meter, 0.5 meters. All right. Okay, so here's our steps. Draw first and label. What do we know? What do we need? What equations are needed? Calculate it, and does it sound about right? All right, look at my wonderful drawing. 1.3 meters by 50 centimeters. You can cross out the 50 centimeters after you've converted it and put 0.5 meters, okay? Just to simplify things. Moving on. Yes, have this cylinder in your notes, okay? All right, here's my notes. My height is 1.3 meters. My radius is half a meter, and I need to figure out what the area is. Okay, now the area is based on a couple of different things, and I'm just going to go ahead and open up a marker here really quick. Let's find an appropriate color. All right, when we look at the area of these two things, you've got the cylinder, right? Wonderful sketch here. Sorry, it's... I don't like it. Here we go. Okay. There's our cylinder. You've got the top, the bottom, and then this wrapped piece here. Well, this wrapped piece, if you can imagine that you just cut it and unfolded it, is really just a rectangle. And so you've got a rectangle and two circles. So when we look at the equations needed, we've got the area of the ends, which is here. I'm going to shut down my, my pen here. We've got the area of the ends, and then we've got the area of the base. That's the wrapped portion. So this is how you calculate area of a rectangle, and this is how you calculate the area of a circle. Okay, so you're going to do the circle twice, so that's why it's 2 times. Okay, there's our knowns, what we're trying to find, and the equations needed. Just following the steps. Here we go. After you do the math and you calculate it out, does 5.65 square meters sound possible for an answer? Sure it does. If you took all that material, spread it out, would it come up with that much area? That does sound appropriate. Now, if you had something like 565 square meters, you're talking about, geez, the whole science wing times 3. So obviously, no, that wouldn't make sense if you just unfolded that one little barrel, okay? But 5.65 meters squared does sound reasonable. So those are those steps, okay? All right, this is a second example. Pause it, write it down. You're not going to have to write down any more examples today, so we're kind of flying right through this. Pause the recording, though, and write down about this gardener, okay? Go ahead. All right. What are we looking at? We're looking at a gardener that has a rectangular plot measuring 3 meters by 4 meters. Just a rectangle. All right. She wishes to use half of it to make a triangular flower bed. The gardener needs to know the total length of the sides to place a row of stones around the perimeter. As well, she'd like to know the angles of the acute angles of the triangles. Okay, she wants to know the angles of the acute angles of the triangle. One of them's a 90 if you can think about a rectangle cut in half. So let's see what we're going to need to solve this. Ready? All right, there's my drawing, 4 by 3. She wants to go and take half of this plot and put a row of stones. And she also wants to know what's this angle and what's that angle. Okay? All right, easy enough. First off, we've got our knowns, side 1 and side 2. We need to find a missing side, okay? Going back to math class, you think of the Pythagorean theorem, you think of a squared plus b squared equals c squared. Pretty simple enough. We can perform that. And our equations, there we go, okay? And then we're also going to need the sine, cosine, and tangent rules from math. Some of you may have heard these before, some of you may have not. You'll appreciate the fact that we're going to bring them in right now, because when you do get to math class, you go, I already know about that. Okay. And then this is just a little helpful hint, SOHCAHTOA, jot that down. All right. Basically what this is this S right here for sine, this C for cosine, and this T for tangent. And the OH, the AH, and the OA stand for what sides you know about: opposite hypotenuse, adjacent hypotenuse, opposite and adjacent. And when you have 2 of those sides, you can figure out missing angles, okay? So these are the equations that we're going to use today, all right, for this problem, for this garden plot problem. All right, whoops, that's the assignment. I need to draw. So hold on 1 second. We're going to figure out this problem, but I'm going to use a sheet of paper and a darker color. There we go. Okay. What do we know? What do we know? What do we know? We know we've got a rectangle. Cut in half. And we've got 3 by 4. And we need to know that side. That's a crappy question mark. But we want to know that side so we can go ahead and find out the perimeter that she needs. Okay? So here we go. We're going to go ahead and take Pythagorean theorem. All right? A squared plus B squared equals C squared. A squared is any one of these two sides, B squared is the other one, and C squared is always the hypotenuse, the longest side of any right triangle. All right, so we're going to take 3 squared plus 4 squared will give me that missing side. All right, 9 plus 16 equals C squared. All right, this is 25. All right, and some of you may know this, some of you may not, but to get rid of this square right here, I square root. And when I square root this, it gets rid of that square there. All right, but I have to do it to this side too. And when I square root 25, what do I get? I get 5. And there is my missing side. So to answer the question, what's the perimeter of the stones? Well, she needs 5 meters, 3 meters, and 4 meters. So she needs 12 meters to go ahead and completely get stones around her triangular flower bed. Okay? I'm going to go to a new sheet of paper because we need to also determine acute angles. Now, I'm going to take that triangular flower bed away from it being the rectangle. All right, just to kind of eliminate some confusion. All right, we need to know that, and we need to know that, and we know this. Okay, all right, here come those sine, cosine, and tangent rules. And so what we have here, and I'm going to jot this, you're going to want to memorize that. Okay, what we know is we know we've got a 3 and a 4-sided right triangle. All right, we don't need a third side on there. But what we're going to do is we're going to pick one angle and solve for it, and then that'll give us all the others. Okay, so let's go ahead and find this one. And the symbol we use looks like that to find a missing angle. That's an unknown angle. Okay, so we need to look at this angle, and we need to figure out what sides do we have. If we know what sides we have in accordance to this angle, then we can pick the rule, and then we can go straight to our calculator and solve for that missing angle. Okay. When I'm standing right here, all right, if I'm standing here, this is me. Okay. This side here is adjacent to me. All right. So I'm going to put a little A. Okay. This side's all the way over, way away, and it's opposite of me. And this side here is always the hypotenuse. Okay? All right. I'm going to get away from that problem for a second. What if I'm standing here? Okay? If I'm here at this angle, okay, now all the way over here is opposite. This one's next to me. It's adjacent. And this one is always the longest side, called the hypotenuse. Okay? So depending on which angle you pick on, depends on where the opposite side is, the adjacent side, and the hypotenuse. All right, let's get rid of that and go back to our problem. Here we are. Get me out of there. Okay. There. So let's solve for this angle right here. Ready? Okay, so what sides do we know? We know the A and the O. Go up here to your tool, all right? You know A and O, okay? And now, so we're going to go ahead and use, on our calculators, the T is short for tangent, all right? And so the rule is that the tangent of some angle is equal to the opposite over the adjacent side. Okay. If I was doing cosine, then I would have known the adjacent side and the hypotenuse numbers. And if I knew those, it would just be the cosine of that angle is equal to adjacent over hypotenuse. The first one here goes over the second one. Okay, so we're going to do some real simple division, obviously, and we're going to use our calculator to do the rest of the work. Okay, so watch this. Ready? The tangent of this angle is equal to, the opposite is 3, and the adjacent side is 4, and so that's 0.75. Okay, just bringing down the stuff that I'm not working on. And so now I want to get this tangent out of here, and I want to be left with just, hey, what's the angle? Okay, and so to get rid of this tangent, on your calculators, let's look at one. On your calculators, and I hope you guys can see this, I can't see myself on the screen, but there's a tangent, and there's a cosine button, and there's a sine button, and above them is the same symbol, but with a -1 above it, okay, and that's the inverse. And so what we're going to do is, on our calculators, we're going to find the inverse tangent of 0.75, all right? And so when we do that, and again, I hope you can see this. We're going to go ahead and do inverse tangent, all right, of 0.75, okay, and that gives us a number. That's the angle, all right. Now your calculator has to be set in the proper mode, and if I go to mode, I'm in degrees, not radians, okay. So that's the angle right there, 36.887. Let's round it up to 37, okay? So this is a 37-degree angle. This is a 90, all right? And so if that's a 90 and all three angles have to add up to 180, then I take 37, subtract that out of 180, and then subtract out that 90 also. I guess the same thing would be just to take 90 and subtract out 37. All right, and we got 53. So I just found out what the two acute angles are on that gardening plot. Remember, in your calculator, type in tangent -1 of 0.75, and that will give you the answer. If you don't have that type of calculator, this does the same thing. All right. Again, it's got the tangent -1. And so if I put in 0.75 and tangent -1, you've got your 37 degrees. Subtract that out of 90 and get your other angle. Okay? All right. That's how you perform acute angles and missing sides, Pythagorean theorem, okay? I know I'm probably running over. I think the screencast let me do 15 minutes. Feel like I'm way over it, so I'm gonna go ahead and give you an assignment to bring in on Monday. You don't have to calculate it. You do have to have the problems written out in your notes though, okay? I told you the other day when you were leaving, on Friday, to make sure that you have watched the screencast, and as well I would give you certain instructions, okay? Those instructions are this, all right? Come to class with 2 problems written out and ready to try in class, all right? As well as the notes from the rest of this, okay? So not a real crazy assignment, is it? Here are those 2 problems. All right, and I'm going to go ahead and try and see if I can put this on full screen. There we go, 74 and 75, okay? 74 says to go to a football game, you first drive 1,000 meters north, then 500 meters west. What's the straight line distance from your home to the football field? Okay, so that is that Pythagorean theorem type question, okay? Have that written out, and we'll solve it in class. All right, 75 says, and we're going to do this one also, Two equally long chains of 1 meter are used to support a lamp, as shown in figure 1.22. The distance between the two chains is a meter along the ceiling. What's the vertical distance from the lamp to the ceiling? Okay, what's the vertical distance? All right, I'm going to add something to this. All right, would you also write down, after this little question mark, would you also write down, I would like to know the angle between the chain and the ceiling? All right, it's the same angle as over here. You only have to do it once, but I want to know the angle from the chain to the ceiling. Okay? Come in on Monday and be ready to do these two questions. You don't have to work them out before. It's all right if you don't. Okay? But this is what we're going to do for some time now. Is we're going to look at word problems. We're going to do sketches when necessary. Can you see how easy it would be to sketch out that triangle in the ceiling? In order to make yourself visualize what we're looking at, okay? We're going to calculate and perform. We're going to use the appropriate equation, and we're going to ask ourselves, is it reasonable? All right? If you get done with this problem and that lamp is hanging 37 meters down, you probably did something wrong, okay? So there we go. That's the end of this screencast. Have your notes and have these two problems written down for tomorrow, all right? Ichabod, thanks again for helping me out. We will see you later.